Good day to you children. Welcome to your second chapter of mathematics, that is Introduction to Euclid's Geometry. The very first question that comes to our mind is, what is geometry? The word geometry is composed of two words, geo plus metron. The word geo means earth and the word metron means measurement. Thus, geometry is nothing but measurement of earth. Although there are many accounts of development of geometry throughout the history, the most notable one goes to a Greek mathematician Thales. He was the person to have given the very first known proof in mathematics. One of the Thales' most famous pupils was Pythagoras, whom you have heard about. Pythagoras and his group discovered many geometric properties and developed the theory of geometry to a great extent. At that time, Euclid, a teacher of mathematics at Alexandria in Egypt, collected all the known work and arranged it in his famous book called as Elements. He divided Elements into 13 chapters, each called a book. These books influenced the whole world's understanding of geometry for generations to come. In this chapter, we shall discuss Euclid's approach to geometry and shall try to link it with the present day geometry which we learn in our everyday life. In the beginning, geometry was an abstract concept. The notions of point, line, plane or any surface was derived from what was seen around the people. Alright, but Euclid changed this view of geometry. He gave definitions, he gave concrete definitions to these geometrical elements which we use in our everyday mathematics. So let's start looking at the definitions of point, line, line segment, straight line, surface and so on. According to Euclid, a point is that which has no part. That means for a point there is no length, no breadth or even height. Now looking at line, Euclid said that a line is a breadthless length. That means for a line, when we draw a line, it does not have any thickness or any width to it. It only has a one dimension, that is length. Based upon the definition of a line, Euclid also said that the ends of a line are called as points. It is true, right? It makes sense. Whenever we draw a line, at the ends of the line we always say that there are end points. So ends of a line always have points. A straight line. Euclid said that a straight line is a line which lies evenly with the points on itself. I repeat, a straight line is a line which lies evenly with the points on itself. Fifth one, a surface. A surface is that which has length and breadth only. For example, the screen right now, your screen which you are seeing right now is a surface. It has both length and a breadth. Thus, surface is a two-dimensional geometrical element. Also, just like how the ends of a line were points, the edges of the surface are called as lines. Lastly, a plane surface. A plane surface is a surface which lies evenly with the straight lines on itself. Starting with his definitions, Euclid assumed certain properties which were not to be proved. These assumptions are actually obvious universal truths. He divided them into two types. The first one was axioms and the second one was postulates. So in this section we will look at Euclid's 7 axioms. First, let us understand the meaning of the word axiom. An axiom is a statement which is accepted to be the truth without any proof. For example, the sun rises in the east. It is an axiom. You cannot prove it. Similarly, the sun sets in the west is an axiom. These statements do not need any mathematical proof for them to be true. They are accepted to be the truth from our observations and experiences. Euclid gave a number of axioms, but for our syllabus we have only 7 of his axioms. The first axiom is things which are equal to the same things are equal to one another. This is the first axiom of Euclid, not in his order but in the order which is given for us. Okay, things which are equal to the same things are equal to one another. To understand what this means, let us consider the example. Let us draw 3 line segments. 3 line segments of length 3 centimeters. Line segment 1, line segment 2 and line segment 3. Alright, all these line segments are of equal length. Let us name them. This is line segment AB, which is 3 centimeters, and the second line segment be named as CD, which also has the length of 3 centimeters, and the last line segment EF, which is also of the length 3 centimeters. Now we know that AB is equal to CD because both the line segments are of the same length, that is 3 centimeter. Similarly, CD is equal to EF. Agree? Because CD is 3 centimeters and EF is also of the same length. So look here, AB is equal to CD and CD is equal to EF. So AB is equal to CD and CD is equal to EF. These two, the line segments at the end, are equal to the line segment in the middle. Thus, I can confidently say that AB is equal to EF. Right? AB is equal to EF. Things which are equal to the same thing will be equal to one another. AB is equal to CD and EF is also equal to CD. These two things are equal to the same thing, CD. Therefore, AB will be equal to EF. This is the first axiom of Euclid. Euclid's second axiom says that if equals are added to equals, then the wholes are equal. For example, we know that 5 is equal to 5 and 2 is equal to 2. Each and every number is unique. There is no other number which will be equal to 2 other than 2. Agree? So, 5 is equal to 5 and 2 is equal to 2. These are equals. Now, let's add them. 5 plus 2 is equal to 7, right? The first 5 and the first 2. After adding them, I got the whole to be 7. Similarly, the second 5 plus the second 2. The second 5 plus second 2. What will I get once again? The whole is, or the sum is once again 7. Here, whole means sum. Alright. So, 7 is equal to 7. In the end, we get 7 is equal to 7. So, if the equals are added, then the wholes will be equal. The third axiom says that if equals are subtracted from equals, then the remainders are equal. This is the reverse operation of the second axiom. In second axiom, we added equals to equals. Thus we get the wholes or the sums to be equal to one another. Whereas in the third axiom we are going to subtract the equals from equals. Then we will see that the remainders or the differences which we get will be equal. For example, x plus 3 is equal to y plus 3. Right? These are equals. Now I am going to subtract equals from this. That is, I will subtract 3 on both sides. Then I will get x plus 3 minus 3 because I am subtracting 3 on both sides, and y plus 3 minus 3. Subtract 3. 3 is an equal, right? 3 is equal to 3. So I am subtracting equals on both sides. Plus 3 minus 3 cancels out, plus 3 minus 3 cancels out. All we get is the remaining terms, that is x equal to y. This is the answer. So look here, x plus 3 was equal to y plus 3. These were equals. And I am subtracting 3 is equal to 3, that is 3 from both the sides. X plus 3 minus 3 is equal to y plus 3 minus 3. Plus 3 minus 3 plus 3 minus 3 cancels out. The remaining or the remainders are x and y. So x equal to y will be our answer. So equals, when subtracted with equals, the remainders will be equal. This is the third axiom of Euclid. In the fourth axiom, Euclid says that things which coincide with one another are equal to one another. That means if two things fit perfectly on top of each other, they will be equal to each other. Just like you studied in the triangles chapter last year. In the triangles chapter, you studied something known as congruency. In congruency, we used to prove that two given triangles were congruent. What that means, we were proving that the given two triangles were exactly identical to one another. So if I were to give you an example, consider a line segment of 5 centimeters. This is a line segment of 5 centimeters. Whenever you draw a line segment, it is necessary that you draw the end points to it. Consider a line segment AB which is of length 5 centimeter and C be a point which lies between A and B. Similarly, consider another line segment DE. This is also of length 5 centimeters. So now in case of AB, I can write it as AB is equal to AC plus BC, right? AB is equal to AC plus BC, which can also be said that the line segment AB coincides with the line segment AC plus BC. That means when things coincide with one another, they are equal to one another. Here, line segment AC plus CB. AC plus CB is also a line segment which is equal to the bigger line segment AB, and they are lying on top of each other and they are exactly identical to each other. So they are equal to one another. That is what this equation says. Line segment AB is equal to line segment AC plus BC. Similarly, look here, line segment AB is 5 centimeters and line segment DE is 5 centimeter. AB is equal to DE. If I were to place them on top of each other, they will perfectly fit or they will coincide with each other. Thus, they are equal to one another. That is the fourth axiom of Euclid. things which coincide with one another are equal to one another. The fifth axiom of Euclid is considered to be the universal truth. That means it is true wherever you go in this universe. Say for example, if you go to Jupiter, even this axiom is true if you are present on the planet Jupiter or Pluto or on some another star that is present in our universe. So the fifth axiom states that the whole is greater than part. The whole is greater than part. For example, consider Earth and India. India is a part of Earth. Agree? India belongs to Earth. It lies on the surface of Earth. It's our country, India. It lies on the Earth. So, which is bigger of these two? Is Earth bigger or India bigger? We know that Earth is greater than India. It is huge than compared to our country, India. So, Earth, when India is part of the Earth and Earth is the whole. Whole is always greater than the part. Similarly, if I were to give you a daily example, then have you eaten chapatis? So which is bigger? Half chapati is big or one chapati is great? Obviously, one chapati is always greater than the half chapati, because half chapati will be the part of the bigger one, the whole chapati. The statements of last two axioms are as follows. The sixth axiom says that things which are double of same things will be equal to one another, and the seventh axiom is the reverse of that. In the sixth axiom, it states things which are double of same things, that is double of 2 is 4. It's like that, doubles. Okay, 2 times. Things which are double of same things will be equal to one another. Similarly, the reverse statement of that is the seventh axiom, says that things which are halves of the same things will be equal to one another. Like the half of 4 will be 2. Okay, so things which are halves of same things will be equal to one another. These are 7 axioms of Euclid. Moving on, we'll look at the 5 postulates of Euclid. Just like axioms, postulates are also the statements which are accepted to be the truth without any kind of proof, but they belong to a particular branch of study. In case of Euclid's postulate, these are the statements which are accepted to be the truth without any proof and are only for the field of geometry. As said before, there are 5 postulates given by Euclid and they are only for the field of geometry. They cannot be applied to any other field because postulates belong to a particular field of study. So Euclid's postulate, the first statement is a straight line may be drawn from any one point to any other point. So here it is a straightforward statement. Let this be point A and let this be point B. So this is point 1 and this is point 2, A and B. So now let us see if we can draw a straight line from point A to point B. So yeah, it is possible to draw a straight line from one point, that is point A in our example, to another point, that is point B in the second example. Similarly, if I were to take any two other points like C and D and try to draw the straight line, okay, yeah, it is possible to draw a straight line once again from any given 2 points, 2 distinct points, okay, any given 2 distinct or different points. So this is the example for the first postulate. The first postulate inevitably leads to 2 more axioms, that are only one straight line can pass through given 2 distinct points and many lines can pass through a given point, which can be verified pretty easily if I were to take some point O. This is the point O, and let's see how many lines can be drawn through it. This is line 1, line 2, line 3, line 4, line 5, yeah, just like this, line 6, line 7, line 8, and so on. Infinitely many lines can be drawn through, or infinitely many lines can pass through any given single point. Similarly, if I were to take 2 points P and Q, and let's see how many straight lines can pass through this P and Q, both P and Q at the same time. Okay, one line, this is one line which can pass through both P and Q at the same time. Is there any other line possible? Look here, no, it only passes through P, not Q. Here it only passes through Q and not P. So similarly, these lines, there are no other lines which will pass through P and Q at the same time. So there is only one straight line that can pass through given two distinct points. Similarly, infinitely many lines can pass through a given single point. This is the first postulate of Euclid. The second postulate states that a terminated line can be produced indefinitely. So if we consider a line segment, a terminated line is nothing but a line segment which has been ended or which has been stopped at some particular point. So if we consider the line segment PQ, according to the second postulate, it says that a terminated line can be produced indefinitely. It says that I can very easily extend this given line segment on the both sides to infinity. So let's see if we can do that. Let's start extending from side Q. Oh, it goes on like that. It goes on. Similarly, from side P, I can go on, keep extending the line segment to my left side. So any given terminated line can be produced or extended. A circle can be drawn with any center and any radius. That is the third postulate of Euclid. You have already experienced it. You can draw a circle with any given radius like 3.5 centimeter, 5 centimeter, 1 meter, 2 meter, 3 centimeter, like that. Similarly, the center can be anything. It can be O, P, M, A, B, Q, C, anything. So a circle can be drawn with any radius and any center is the third postulate. The fourth postulate says that all right angles are equal to one another. That is, all right angles are equal to one another. The measure of the right angle is 90 degree. Any given right angle is always equal to 90 degree. So obviously, no matter how many right angles you draw, they are always equal to 90 degrees. So the fourth postulate says that all right angles are equal to one another. They are talking about angles, not triangles here. The right angles, that is 90 degree angles, are equal to one another. For now, let us deal with these four postulates. The fifth postulate of Euclid will be taught to you in a later class.